Welcome to the first episode of Ingram's AI podcast. Today, we are diving into the part of AI that doesn't get enough coverage on LinkedIn or social media. My name is Ali Baghdadi, and I'm a Senior Vice President at Ingram Micro. Today, I'm very lucky to have Mr. Baris Kukakai.
Kuchakai, that's good.
Okay, good. Regional Director of Corning Incorporated. Baris, very welcome.
Thank you.
I'd like to take us through an adventure here and talk about various things relating to Corning and to the cabling and very important role of cabling in the AI as of today. So I have a question for you. AI systems are like humans today. So why should an AI system thank your cabling team?
Well, first of all, thanks a lot for the invitation. It's a great pleasure to be here, Dr. Ali, and to the Ingram team. Obviously, AI is going on an incredibly fast pace, and I call the cabling as the nervous system. If the signal from your brain doesn't reach your hand instantly, your hand's not going to work. And here is the key factor here is the instantly. So the nervous system of your AI infrastructure is the optical fiber. It is a bit of an unsung hero in the recent AI and machine learning infrastructure. However, if we need to look into the details, we need to understand how AI computing is different than the traditional cloud computing. So traditional cloud computing is like in the old days, which is like 5-6 years ago, where you have a server and a user wants data and a web page and server fetch this. It's a one user, one server, transactional, simple system. Although it's very complicated, don't get me wrong. But now with the AI computing and machine learning, you're having thousands of parallel tasks at the same time.
That's true. That's so true. Oh, very good description, Baris. So we all talk about GPUs, TPUs. We have Google next door talking about their TPUs, and GPUs are from NVIDIA and AMD and so forth. So where does structured cabling come into this technology?
So when you build an AI cluster, I think minimum you need to start with 1,000 GPUs, and it goes up to tens of thousands of GPUs. What really matters is these GPUs physically connected to each other. Mm-hmm. So the topology and the network architecture is changing. The leaf and spine architecture, which is not the name of a yoga pose, is actually a very important connectivity matters, physical connectivity. So when tens of thousands of GPUs connects to each other, there has to be a pure flow of information with ultra low latency. So why structured cabling matters and why it is different right now is basically if you have a problem in your highway, you're going to have the traffic, the network congestion, which is going to end up with latency, and that's going to end up with port flapping. And what happens? Your entire GPU cluster speed will be the speed of the lowest package delivered. So your slowest connection out of these tens of thousands of links will be your speed. So your AI cluster will not be intelligent anymore.
It's really interesting as you speak about GPU clusters talking to each other, communicating with each other. So NVIDIA has been working on some new technology, which actually they call the copper revolution, where on a single board they cluster many GPUs connected by copper wiring at the back of the actual board. So does this compete with the structured cabling that connects GPUs to each other today? And how is Corning going to provide solutions outside of this clustering.
Absolutely. So again, when I go back to the traditional data center and traditional networking, in the old days when we have 144 fiber into one server rack, this means future proof. This meant future proof. Currently, NVIDIA's new developments, and it brings every year new servers, highest available GPUs. It goes up to thousands and even tens of thousands of fiber. And then when we talk about it, it's between the racks. All right. So at the same time, NVIDIA as well as Broadcom now working together with Corning, a technology called co-packaged optics. This is bringing the fiber into the chips directly into the chips.
That's fascinating, because one of the things that I've usually looked into is the actual transceivers that convert the electric signal, the optical signals and the fiber to electric signals. So you are bypassing that, because these transceivers consume power and they slow things down.
Absolutely.
So you're overcoming that. This is new technology?
It's a new technology. And when I go one step back, it's obviously the optical fiber, and you have light transmitting between the transmitter and the receiver, right? That's the optical link. And then, in the beginning with the copper system, the electrical signals converted into light signals, laser. And at the other end of the link, there's a transceiver converting the light into the electric signals into data. Right now, with the co-packaged optics, when the fiber reaches to the chip, so amount of power required with this conversion, you're doing twice. The amount of power required for this will be 5 times less. So imagine a data center and an AI factory spending 5 times less power electricity.
That's incredible. I mean, that power consumption of AI data centers is the biggest question of the day, right? So you're solving that, or helping to solve that. That's really great. So my next question, let's say, is what happens if people just put more cables to make this solution work between GPUs, even with your new introduction of these optical cables that doesn't consume power? Throw more cables.
Yeah, that's actually very, very simple. If you are having issues with the speed or the connectivity, you pull more cables point to point. But I call this you're building a house without pipes.
Okay.
Imagine you have a house and no need for the pipes, and every time you need water, you go to the garden, pull a garden hose into your kitchen and have a glass of water. Do you do that? You don't do that. So it's the same concept. When you have the data centers, you bring the fiber as your network, as your nervous system, the trunk fiber, the high density, ultra high density fiber, install there, and then enable your scalability and then future proof. So this is going to help you, first of all, with the human error. As I said, when you have a couple of hundreds of fiber connectivity, it's easier to take care of these issues. Troubleshootings were much easier. You send the IT technician, he's gonna do the patch course. If there's any mispatching, he'll do it. But imagine, again, you have 10,000 fiber, point-to-point fiber, and then there is a lot of big risk of mispatching.
That's
a lot of human error. It's going to take a very long time for troubleshooting, and an upgrade's going to take longer as well.
So definitely messy cables lead to a messy
absolutely
performance and
modular approach and a structured cabling. Building your house, your building with the proper pipes and the plumbing is a simple analogy here.
Okay, let treat me as a younger person, although I'm not young at all, but
you are.
If you explain why would you use light to travel through glass instead of electricity in copper?
Correct.
That's what we know, right?
Yeah, that is the definitely important question. It again is a metaphor, but copper, you're in a highway and you have lots of cars traveling slower, congestion, generating heat. and are not very efficient. But when you're with the fiber, you have the light traveling inside a very thin, purest glass. This is the fastest, number one, fastest way of transmitting. Number two is the highest amount of data. And number three is the farther. The longer distances can be achieved with this. It's at the end of the day, it's the speed of light.
Amazing. Before we get into the history of Corning, I have another question. So we're connected here at Ingram with SpaceX, and we distribute Starlink, and we know, and we are in discussions with them about the data centers that they're building in the sky. Now they tell me that they can transmit data, let's say from New York to Sydney, at a high speed because it's going through space. Okay, it might be slower bringing it down, but do you also cater for underwater cabling, and how will you compete with something like SpaceX's data centers in the sky?
So I think the recent communication era, the fundamental building block is optical fiber as a thin glass strand, thinner than your hair, under the oceans, between the cities, kilometers, thousands of kilometers. The most important thing is very reliable. It's a technology going on for over decades, fine-tuned, and a lot of innovations are happening. So the optical fiber is going to continue to be the building block. There will be obviously alternatives. We are running out of space. We are running out of cooling options. We are running out of, we need more efficiency. We are obviously power and electricity. When we're in space, it's pretty much the free power and everything. So,
I mean, the demand for AI is growing so fast, to the extent that we're not even building enough data centers today, and that's even driving the cost of chips, technologies high. Everything is getting more expensive electrically and electronically because of the demand being so high. So there will always be the demand. And as you say, we've got reliable technology, well tested, and we're yet to see data flying between satellites. So yeah, it's very good. Now let's go back to Corning's evolution. I find this absolutely fascinating. Corning has been around for some time, and you'll tell me how long they've been around for. But I didn't even know that Corning was making glass and making something called Pyrex, which my mother used to use in the kitchen. So what's the history of Corning, really? Where did it come from?
Yeah, that's quite interesting. This year we're celebrating 175th year anniversary.
175th year.
Not 75, 175.
What? Yeah, that's a long time.
Yeah, founded in 1851 as a glassworks company. Still, you look into Corning in the stocks. The symbol is GLW, Glassworks. That's how everything started. Obviously the kitchenware and etc. Pyrex is still a trademark of Corning, although it's not in our business anymore. But that is a lot of history lessons. Some people might find this boring, but it's, as I said, sometimes it's fascinating. It is 1908, Corning developed the glass envelope for the Thomas Edison's light bulb.
Okay.
And then imagine that. Yeah, since then, it continues innovating. Its innovation is in our culture. And a lot of life-changing innovations. So TVs, the cathode ray tubes, and later on the ceramic substrates for the cars, catalytic converters, the display technologies, LCD screens, as well as now the Gorilla Glass, the electronic-enabled glass in our telephones and our tablets. And obviously, then there's a lot of space exploration. The Hubble telescope, James Webb telescope, the International Space Station glass. All these are within the innovation scope of Corning over these 175 years. And the most importantly, last 50 years, more than 50 years, is the optical fiber. Corning is the inventor of first low-loss optical fiber in 1970.
That's incredible, really, from light bulbs and kitchenware to AI and driven by optical fiber. I didn't know many of the things that you just mentioned actually as inventions.
It is nearly, if you think about 175 years of wars and world wars and Great Depression and economical crisis, etc., and surviving it is pure on the innovation of the material science and glass and ceramics.
Incredible. Let's get back to the benefits of structured cabling for AI. If I'm a CIO of a data center, and what do I gain from taking structured cabling seriously for AI specifically?
Yeah, the investors and the C-suite, CIO, CEO team of people, obviously spending hundreds of millions of dollars of capex for the AI factories and AI infrastructure. We actually would request them to invite the cabling people to the meeting, which never happens and is not going to happen probably. However, when you have the data scientists deciding on the model, right? And then the hardware people working on the best configuration of the servers and the GPU design, and you have the facilities people arranging the building and then deciding what to do, and the electricity and power and cooling, etc., is always the cabling part. The connectivity is forgotten. Imagine you're building a Formula One circuit, spending millions of dollars, hiring the best race team, and getting the fastest car, and you put a bicycle tire in your Formula One car.
Wow.
So we would ask the CIOs maybe respect the physical layer for the ultra low latency systems and the fastest possible efficient way of GPU. And as I mentioned before, the modular approach and the structured cabling approach. CIOs or the network infrastructure team at least should consider designing a high density day one. And then having the modular approach, so in the future of growing it, adding it, moves and changes, etc., it'll be, your trunks will be in between. And then your ports will be there, and with simple patch codes you can change and adapt it very fast. And then third advice would be the future proof of the speed. So 10 gigabit, 100 gigabit in a traditional networks. Now AI factory is running on 400 gigabits. At the moment, it is 800 gigabits. Couple of years, we're preparing for 1.6 terabit per second. These are the speeds we're talking about. A single speck of dust in that fiber connector is going to make your network fail.
That's absolutely true. I actually have a small experience recently as a person, not as a CIO, but I test various AI platforms from my home office. And one day I was just looking out of the door of my place, and some people were connecting from actually were connecting fiber optic cables in the building to replace the traditional cables. And they said, well, test your internet speed now. And amazingly, it was like significantly faster just once I plugged in again. So yeah, I mean, I can vouch for that for sure.
Absolutely.
Just one last question before we wrap up. Have you ever seen a mysterious issue that turned out something strange that really happened because of structured cabling deployment?
So when we have the copper system, the copper links, right? You have the copper wire as the medium, and the transmitting is the electrons. The electrons are carrying the data. These are slower and, as I mentioned, not very efficient and generating heat, etc. However, they are more forgiving to the errors. All right. So when you're with fiber, you're working with light, and light doesn't want to turn corners. Mm-hmm. So we're talking about in the AI environment, thousands or tens of thousands of fiber in a very, very tiny server racks. So you have to make sure this system is going to have the capability and the density and physical properties to turn the corners or arrange your network accordingly. So if you don't pay attention to these details, there will be issues like the network people call port flapping. There's a lot of latency, slowdown in the network, And the GPUs, if they don't receive the packets, they sit there and continue working. So imagine you're still paying for the electricity, it draws power. You're wearing out your hardware, and then you have to pay more for your cooling. And then at the end of the day, is not delivering the results supposed to be delivered. So these are the really, really important aspects, I think, which is all considered.
So you're allowing your technology to actually, the light which travels in a straight line, you're finding a way to make it maneuver in terms left and right.
Yeah, absolutely.
Yeah. That's, again, another amazing factor. So let's wrap up with practical advice. So if someone is refreshing their AI environment now, what would your top 3 cabling recommendations?
Would be, I think, speed, scalability, and sanity. So we talk about it all the time. 800 gigabits will be the minimum. That needs to be the minimum standard during the design stage. And then obviously you need to have the scalability. You need to scale it with the higher density. And the sanity is the most important, maybe. That it not just doesn't have to look good, it needs to look good, obviously. But there are lots of cables cascading like waterfall, all of the orange, yellow, and aqua color in front of your server rack. It's going to create an air dam. It'll stop the cool air flowing in and then cooling your servers and GPUs. So sanity is so important, and this can only be achieved with really the modular and the structured cabling approach. Day one.
That's very, very good advice. Thank you so much. So, and if our listeners take only one action after this episode to thank their cabling team, what should it be?
I would humbly request them to respect the physical layer.
Okay, thank you. I love that. Anyway, let's invite the cabling team to our next AI meeting.
Please, we're here, and then we'll do our best to make it as future-proof as possible.
Perfect. Baris, thank you so much.
Dr.
Good
Ali,
to see you again.
Thanks for having me.
And all the very best.
Appreciate it.
Thank you.
Thank you. Have a great day.
Thank you very much for watching this episode and for being with us today. We have so many new things coming up in this world. AI, of course, right now is leading, and we will be continuing to make new episodes covering new technology. Thank you again.